Hello everybody, I'm Suman Matthews and today we will be discussing the topic differential equations. This is a part of graduate engineering mathematics. We will be discussing the topic non-linear differential equations. This is a two-part video and this is the first part of this topic. This channel has videos for grades 11, 12 engineering mathematics and the GRE quantitative section. Consider subscribing to my channel and hit the bell so you get notified each time I publish a new video, or you can visit my page. This is a link for that page. There is also a playlist which you can click on. Feel free to send me your queries, and this video is problem oriented. This presentation explains what are nonlinear differential equations and the technique to solve them. Problems 1 and 2 illustrate how to solve a nonlinear differential equation. Problem 3 shows that when you get a function of the form y equal to a function of x and p, we solve it for y, that is, we differentiate with respect to x, and we also learn to substitute the value of p in the final equation to get the general solution. Consider a differential equation a0 p raised to n plus a1 p raised to n minus 1 plus a2 p raised to n minus 2 plus an equal to 0, where p is dy by dx. So this is a first order differential equation of what degree? Nth degree, because it is p raised to n. Suppose we write this as a product of n linear factors: p minus f1 xy, p minus f2 xy, p minus fn xy equal to 0. This is when you factorize it. So when you have the product of n terms as 0, what does that mean? Either one of the terms has to be 0 or all of the terms have to be 0. So I have p minus f1 xy equal to 0, or p minus f2 xy equal to 0, or p minus fn xy equal to 0. So what have we done? We have factored this into n factors, and the product of all these solutions is the general solution of the differential equation. Coming to problems, solve y dy by dx the whole squared plus x minus y dy by dx minus x equal to 0. How do we start? We put p as dy by dx, so I get yp squared plus x minus yp minus x equal to 0. This is a quadratic equation, and using the formula minus b, that is minus x minus y, plus or minus root b squared, which is x minus y the whole squared, minus 4ac, that will give you plus 4yx by 2a by 2y. So what happens when you remove this plus or minus? What is this term inside the square root? This is nothing but x plus y the whole squared. So when I remove the square root, I get x plus y. Now we take two cases with plus and minus. So we get p equal to y minus x plus y by 2y. So you get it as 2y by 2y, which is 1. Or p equal to y minus x minus y by 2y. So what happens? The y get cancels and you get minus 2x by 2y, which is minus x by y. So coming to the first case, p is dy by dx. So dy by dx is 1. So what happens here? You get dy is equal to dx. Integrating, we get y equal to x plus c. When you take all the terms to one side, what do you get? Y minus x minus c equal to 0. Coming to the next equation, dy by dx is minus x by y. What do we do here? Variable separables. So y dy is minus x dx. Integrating, you get y squared by 2 plus x squared by 2 equal to c. And how do you get this? We take the LCM and shift all the terms to the right. So I get y squared plus x squared minus 2c equal to 0, which is same as y squared plus x squared minus c equal to 0. Because if c is a constant, 2c is also a constant. And what is the technique we explained? We multiply the solutions. So the general solution will be y minus x minus c into y squared plus x squared minus c equal to 0. This is when we are factorizing the equation. The best way to learn mathematics is to do mathematics. So take a pen and paper and practice along with me. Coming to question 2, solve p squared plus 2py cot x equal to y squared. Again substituting, before that we solve for p using the formula minus b, that is minus 2y cot x plus or minus b squared, which is 4y squared cot squared x plus 4y squared by 2a. A is 1. So you get minus 2y cot x plus or minus, if I take out 4y squared and I take it out of the square root, what do we get? 2y. And root cot squared x plus 1 is cosec squared x. So root cosec squared x is cosec x. Dividing by 2, we get p equal to minus y cot x plus or minus y cosec x. So what are the two equations? The first one is p equal to minus y cot x plus y cosec x, that is minus y, taking out the minus y you get cot x minus cosec x, or the second one, what do? You take the minus sign. So I get minus y cot x minus y cosec x. Taking out the minus y, I get minus y into cot x plus cosec x. Now coming to the first equation, we get dy by dx equal to minus y cot x minus cosec x. What did we do here? We substituted for p. We do variable separable, so dy by y equal to cosec x minus cot x dx. And now we integrate, so integral dy by y is log y. What is integral cosec x? Log mod tan x by 2. Integral cot x is log mod sin x. And everywhere we have log, we take it as plus log c. So we get log y equal to log tan x by 2 by sin x into c. We make use of the property that log a plus b, log a plus log b is log a into b, log a minus log b is log a by b. So now we can write this as y equal to c tan x by 2. Now what is sin x? 2 sin x by 2 cos x by 2. So simplifying, we get y equal to c by 2 cos squared x by 2, because sin x by 2 gets cancelled. And we get 2y cos squared x by 2 equal to c. Call this equation 3. So what is this? This is a solution of the first part. Now come to the second part. Dy by dx is minus y cosec x plus cot x. Can we do variable separables here? Yes. So we get dy by y equal to minus cosec x plus cot x dx. Integrating, you get log y equal to minus integral of cosec x is log tan x. Integral of log tan x by 2. Integral of cot x is log sin x plus log c. So we get log y. What do we apply here? Log a plus log b is log a into b. So log y into tan x by 2 into sin x is log c, or we get y sin x by 2 by cos x by 2. Again this sin x is 2 sin x by 2 cos x by 2 equal to c. So what gets cancelled? Cos x by 2, and I get 2y sin squared x by 2 equal to c. So this is a solution of the second part. And now what do? We take the product of the two to obtain the general solution. So your general solution is 2y cos squared x by 2 minus c into 2y sin squared x by 2 minus c equal to 0. Now what happens when we cannot factorize it? That is, y is a function of x and p. We solve for y, or we differentiate with respect to x. Coming to question 3, solve y minus 2px equal to tan inverse xp squared. Can we factorize this directly? No. So y is a function of p and x, so we differentiate with respect to x. So I get dy by dx, which is p. Apply the product rule here, so I get minus 2 derivative of x is x, so p plus x dp by dx, and you have the 2 derivative of tan inverse x is 1 by 1 plus x squared. So it becomes 1 by 1 plus x squared p raised to 4 into d dx of xp squared, that is p squared plus x into 2p dp by dx. Now we just simplify. What do we do next? We open this bracket and this bracket as well. So we get p minus 2p, which is minus p minus 2x dp by dx is 1 by 1 plus x squared p raised to 4 into 2xp dp by dx plus p squared. Take all the terms without dp by dx to one side, the terms in dp by dx together. So minus p squared by 1 plus x squared p raised to 4 equal to 1 by 1 plus x squared p raised to 4 2xp dp by dx plus 2x dp by dx. What can we do now? Take the LCM. So we get minus p into 1 plus x squared p raised to 4 minus p squared. by again denominator on the right, we get d2xp dp by dx plus 2x into 1 plus x squared p raised to 4. Opening the bracket, we get minus p x squared p raised to 5 minus p squared equal to 2x dp by dx into, we take out 2x, so p plus x squared p raised to 4 plus 1. So if we take out minus p here, what do you get? 1 plus x squared p raised to 4 plus p. And here also we get 1 plus x squared p raised to 4 plus p. So we cancel both and we get minus p equal to 2x dp by dx. Now can we do variable separables? Yes. So dx by x equal to minus 2 dp by p. Integrating, you get log x equal to minus 2 log p plus log c. Now what happens here? Log a plus log b is log a into b. So xp squared equal to c, or p squared is c by x. And now p is root c by x. Now notice the step here. We substitute this value of c in the original equation. That is a question. So we get y minus 2 instead of p, I get root c by x into x equal to tan inverse px. So it becomes p squared x. So c by x into x, or y equal to 2 root cx plus tan inverse c is the general solution. So we have learned what are nonlinear differential equations and how to solve them. We have learned that when y is a function of x and p, we solve for y, that is, we differentiate with respect to x. And we also learned how to substitute the final value of p in the equation to find the general solution. So this is my channel link, my page link. Consider subscribing to my channel or visit my page, or you can visit my playlist which has videos for engineering maths. I would love to hear your feedback. So the next video on this topic introduces Clairaut's equation. It is a continuation of this topic. Thank you.